Okay, here's audio narration based on the provided information suitable for TTS, focusing on the technical aspects of stray currents. Stray currents are electrical currents that flow through unintended paths existing outside of designed electrical circuits. These currents are often found in underground electrical systems, such as power distribution lines or transit systems. It's important to understand the potential effects of stray currents. They can lead to corrosion of metal structures, including pipes, rebar embedded in concrete, and electrical wiring. Stray currents can also cause interference with sensitive electronic equipment. Furthermore, they present safety hazards, potentially resulting in electric shocks or arcing. Addressing stray currents typically involves several steps. First, identification. This involves determining the presence and location of stray currents using specialized instruments. Second, mitigation. This includes implementing measures to reduce the flow of stray current. Examples of mitigation measures include installing grounding systems to redirect currents to intended paths, bonding metal structures to prevent corrosion, and utilizing insulated electrical cables and joints. Third, calculations. This means quantifying the effects of stray currents and evaluating the effectiveness of implemented mitigation measures. Now let's delve into the calculations required to assess stray currents. 1. Current measurements. Here, you measure the magnitude and direction of stray currents using ammeters and voltage drop measurements. 2. Corrosion rate estimation. This is where you calculate the potential corrosion rate based on the current density and the type of metal involved. 3. Bonding resistance. You must determine the resistance of bonding connections to ensure effective current diversion. 4. Grounding resistance. It is important to calculate the resistance of the grounding system to ensure adequate current drainage. 5. Field strength calculations. This involves estimating the magnetic field strength generated by stray currents, which can affect sensitive electronic equipment. Lastly, mitigation effectiveness. Compare pre-mitigation and post-mitigation measurements to quantify the effectiveness of the implemented measures. By performing these calculations, engineers can design and implement effective stray current mitigation systems, protecting infrastructure, equipment, and human safety.